Welcome to Scispectrum Lab Essentials, your source for equipment, instrument, and consumables.
So we all live in this world that's just bursting with color, right? But what if I told you that color itself is actually a key? A key that can unlock all sorts of hidden information in everything from the water we drink to the food we eat. Today, we're going to talk about the calorimeter, a really cool device that precisely measures color to reveal what's unseen. Kind of sounds like a riddle, doesn't it? I mean, how do you put a number on the color blue? Or how do you quantify the exact shade of yellow in a solution? Well, this is the fundamental problem that the calorimeter was built to solve. It's all about turning something we see with our eyes into hard, actionable data. All right, so here's our game plan. First, we'll break down what a calorimeter is. Then we'll peek under the hood to see how it works. After that, we'll get practical and talk about how to get a perfect reading. And finally, we'll explore where you see this thing in the real world and what's next for this amazing tool. Okay, let's jump right into our first section. So what exactly is this device? Well, at its heart, it's not just some fancy color sensor. A better way to think of it is like a window that lets us see the invisible chemical makeup of a solution. You know, in the simplest terms, a calorimeter shines a very specific color of light through a liquid. Then it measures something called absorbance, which is just a fancy way of saying how much of that light doesn't make it through to the other side. So based on how much light gets soaked up, it can tell you exactly how much of a certain substance is dissolved in that liquid. It's an incredibly powerful tool for chemical analysis. Now for the really cool part, how does it actually pull this off? Well, the magic is all based on a fundamental law of physics, plus a really clever arrangement of some pretty simple parts. The whole thing works because of a principle called the Beer-Lambert law. Now, that sounds super complex, but I promise it's something you already know. Just imagine shining a light through 2 glasses of juice. The one that's darker and more concentrated, it's obviously going to block more light than the one that's all watered down. All this law does is put a number to that relationship. And the calorimeter, that's the tool that measures it with incredible precision. So let's follow the light beam on its little journey inside the machine. It all starts with a simple light source. But we only care about how one specific color is absorbed, so a filter jumps in to block out all the other colors we don't need. That precise beam of light then zips through our sample, which is held in this special, optically perfect vial called a cuvette. Whatever light isn't absorbed by the sample hits a detector on the other side, which turns that light into a number. It's the simple, elegant journey from light to data. Now, here's a crucial point. Just owning a calorimeter doesn't mean you're going to get accurate results. Nope. The machine is only as good as the person operating it. And when it comes to precision, it is all about meticulous, careful procedure. And this gets to what's so interesting about this technology. You've got this sophisticated piece of scientific equipment that can take these tiny measurements, but its accuracy all depends on the most basic, low-tech stuff. How you clean a vial, how you measure a liquid, even how you hold the sample. It's a powerful reminder that in science, precision always starts with careful hands. So let's break down what that really looks like. It really just boils down to these 3 things. Get these right, and your results are golden. Get them wrong, and you're pretty much just generating bad data. Let's take a look at each one, starting with calibration. Okay, so before you measure anything, you have to give the machine a baseline. This is called zeroing or calibrating. You use what's called a blank, which is usually just distilled water, to basically tell the device, hey, this is what 0 looks like. You have to do this every single time you test. Every time. It's an absolutely non-negotiable step. Now let's talk technique. This might seem like a tiny detail, but it is so vital. When you measure your liquid, you can't just eyeball it. Because of surface tension, water actually forms a little curve at the top, called a meniscus. For a truly accurate measurement, the very bottom of that curve has to sit perfectly on the measurement line. You can see it perfectly here. That container on the right, that's the only one that's been filled correctly. And that brings us to cleanliness and taking care of your gear. This quote just says it all. You know, it's tempting to keep using a vial that's a little scratched up to save a few bucks, but that is a huge mistake. A single scratch can scatter the light beam and completely throw off your readings. That wastes time, it wastes expensive reagents, and it can lead to some really bad decisions. So here's your checklist for keeping those cuvettes absolutely pristine. Any fingerprint, any smudge, even a tiny air bubble inside the sample can mess with the light. You have to wipe the outside with special lens paper, and never a paper towel, because that's way too abrasive. Rinse it out right after you use it. And here's a pro tip. Never ever put them in an ultrasonic cleaner. The vibrations can actually shatter them. Okay, so we've covered the what and the how, but why does any of this actually matter? Let's zoom out to the real world and see how this technology is used every single day to keep us safe and improve our lives. And the applications are just incredibly diverse. This thing is definitely not a one-trick pony. Environmental officers use it to make sure chlorine levels in our drinking water are safe. Scientists use it to monitor river pollution by measuring phosphates. And public health officials rely on it to detect dangerous heavy metals like lead. You see this number right here? This is the minimum level of free chlorine that health authorities say we need in our drinking water to protect it from nasty microbes. A calorimeter is the tool that lets a water treatment operator know with absolute certainty if they are hitting this critical safety target. It turns an abstract number into a life-saving measurement. And it doesn't stop at water quality. The food industry uses calorimetry to make sure the color of your favorite juice is exactly the same from bottle to bottle. Pharmaceutical companies use it for quality control. Paint companies use it for precise color matching. It's truly one of the hidden workhorses of our modern economy.